Alright, so now that we've had a chance to discuss the difference between measured numbers and counted numbers and infinitely significant versus number of significant figures, let's take a chance now to see how significant figures are impacted through calculations. And so just be very careful to pay attention to the type of calculation that we're doing and also the order of operations if we're doing multiple types of calculations here, as the rules for addition and subtraction differ significantly from the rules for multiplication and division. Alright, so again, we talked briefly in our last segment about the number of significant figures that you would get in a measured number, and that if it's a digital display, we would take all the digits to be significant aside from leading zeros. If we happen to have a mass, say, of 0.050 grams, then we wouldn't take those leading zeros, but certainly trailing zeros in a significant figure measured number would matter. For an analog device, we would estimate to one digit beyond the certain digit that our device is limited to. The series of calculations you might do with measured numbers will be impacted by whether, again, it's addition subtraction type mathematic operation or multiplication division. And of course, you are smarter than your calculator. Your calculator doesn't know anything about significant figures or the rules therein, so do not trust that your calculator will automatically give you the correct number of significant figures. It almost never does. So if we can't trust our calculator, how do we know what to do? Well, we have some rounding rules. So to make sure that you get the appropriate number of significant figures in your result, you have to apply the appropriate rule for rounding. And here we have two rules. Number one, if the first digit to be dropped is 4 or less, then it and all following digits are simply dropped from the number. So if we had a value of, say, 354.4 grams, and it's really just that ones place that is our last significant digit, then we would simply have 354 grams. That last 0.4 would be dropped, and we would not need to apply any rounding rules. We just drop it off. If that last digit, the first digit that would not be considered is 5 or greater, then the last digit retained would be increased by 1. So if instead of our last example where we had a 0.4 at the end, if we had 354.5 or 0.6 or 0.7, so on and so forth, then we would round up to 355 grams in that example. Okay, we still would limit to the ones place if that's the limit of our significant figures, but now we would increase it by 1 because the first digit beyond the decimal place of significance would be 5 or greater. Alright, so here we see a few examples where we have the number to round off, and the number that we're looking for has just 3 significant figures or 2 significant figures, how we would apply those rules. So for the first example, 8.4234, if we're going to 3 significant figures, that would be 8.42, and then when we look at its nearest neighbor, that's a 3, so we just drop the 3, 4 at the end to get 8.42. If we were looking for just 2 significant figures, now we would look at the 8.4 as being significant, and when we look at the next digit being the 2, we also would just drop it off to give 8.4 as our final answer to 2 significant figures. If we look at the next example, 14.780, if we're looking for 3 significant figures, that would be 14.7, only now when we look to the next digit, it's an 8, so that's 5 or greater, so now we'd have to round up our last significant figure to be 14.8. If we looked to have just 2 significant figures, then it would be 14, but when we see that the first decimal place is a 0.7, now again, because it's 5 or greater, we would round up to 15 for rounding that number to 2 significant figures. Finally, if we have 3,262, we're looking for just 3 significant figures, well, then that would be 3,260. Because the digit in that ones place is a 2, we would just drop it off and represent it as either 3,260 or, even better, 3.26 times 10 to the third, so there's no question that that last 0 is just a placeholder. Finally, if we wanted to look at just two significant figures for that example, 3,262, well, we'd say 3,200, but then when we look to that first digit that's not significant, the 6, that would require that we round up to 3,300, or better yet, 3.3 times 10 to the third. So hopefully with these three examples, you've gotten a little better at figuring out when to apply the rounding rules to round up, and when it just results in a dropping off of those significant figures. Certainly we're going to be doing some other work, and hopefully you'll try additional problems in the text if you're continuing to struggle, like many students do at first, with significant figures in calculations. Now, believe it or not, using multiplication and division is actually the easier case for significant figures, because what you're looking for in your result is a result that has the same number of significant figures as the measure with the fewest significant figures, and then of course apply those rounding rules that we just discussed for the final result's significant figures. So how do we mean this? Well, if we look at the example, 110.5 has 4 significant figures. Multiply that by 0.048, which has just 2 significant figures. Those leading zeros are not significant, they're placeholders. If we rewrote it in scientific notation, of course it would be 4.8 times 10 to the minus 2, so you can always do that if you need help figuring out the zeros before or after, if they're just placeholders. So when we multiply those two values together, your calculator, your silly, naive, non-chemistry student calculator, will give you a result of 5.304. Applying the sig fig rules, we really want just 2 significant figures, right? Because the second calculation, the measured number there, had just 2 sig figs. So our answer should have just 2 sig figs. If we look at 5.3, then we look to the 0 afterward. Of course, it's less than 5, so we retain 5.3 as our rounded value to the correct 2 significant figures. So you're just looking in a multiplication or division application at the number with the fewest number of significant figures, and then making sure that your resulting answer has that same number of sig figs. Alright, so let's pause here with a learning check and see how you're able to apply that idea of significant figure rules for a series of multiplication or division. In the first example, we have 2.9 times 4.2, and go ahead and figure out what the result should be to the correct number of significant figures. For the second example, we have 4.311 divided by 0.07. And then finally, we have, in our third example, 2.54 times 0.0028 divided by 0.0105 times 0.060. So go ahead and for each of those, you really don't even need the calculator, because you're just looking for the result that has the correct number of significant figures. If you need to pause the video, please do so now. Otherwise, we'll take a look at the correct result for each of those examples. Alright, so looking at number 1, where we had 2.19 times 4.2, well, 4.2 has just 2 significant figures, whereas the 2.19 has 3, so we know that our final result should have just 2 significant figures, and therefore B, 9.2, is the correct result. For number 2, 4.311, that's 4 significant figures, divided by 0.07, that's just 1 significant figure, right? Those leading zeros are just placeholders. So our correct answer is C, 60, just that 6 having significance, therefore 1 significant figure in our result. And finally, number 3, 2.54, there's 3 sig figs, times 0.0028, just 2 sig figs there, divided by 0.0105, again 3 sig figs in that first value, times 0.060, just 2 sig figs there. We would expect 2 sig figs in our final result, so B, 11, is the best answer. So remember, take a look at what the calculator gives. For this example, we were just looking at the numbers that made sense, but the reason we went with 11 there for that last example is that we had 11.2888889, so we would round because the 0.2 is less than 5, we would round down to 11. Now, in the examples we've looked at so far, we've been rounding off before we include all the significant figures that our calculator gives. There's also times where the calculator doesn't have enough significant figures, and so that when that arises, that case means that we need to add additional zeros until we get the right number of significant figures. So suppose when we multiply all of our values through, let's say we had 3.00 times 1.33, well, we would end up with something that's very close to 4. If it gave exactly 4 because of the mode of your calculator or because of the particular numbers that you were dealing with, you would not just give us 4 because that's what the calculator said. Instead, if you know that you need a total of 3 sig figs in your result, you would give 4.00. Or if you needed 2 sig figs, it would be 4.0, or 4 sig figs would give 4.000, so on and so forth. So just be careful to add enough zeros in the case where the calculator gives a number with fewer sig figs than you need in order to make sure that you have applied the correct sig fig rules. Okay, so now on to addition and subtraction sig fig rules. These, believe it or not, are usually tougher for the average student to apply correctly than the multiplication and division rules. The multiplication and division rules, again, your result has the same number of significant figures as the least significant value in the strand of calculations. When you're using addition and subtraction rules, what you're looking for is the same number of decimal places as the measurement with the fewest decimal places. And then, of course, you still need to apply the rounding rules we discussed to get the number of digits in the answer. So if we look here in this example, we have 25.2 plus 1.34, and we end up with, again, that tenths place is the decimal place for the first, and the hundredths place is the decimal place for the second. So we want to end in the tenths place, and we end up with a value of 26.5. First it's 26.54, but then because that 4 in the hundredth place is less than 5, we simply drop it off and leave 26.5 as the final answer to one decimal place. Okay, it's possible with addition and subtraction rules that you end up with a result that has a different number of sig figs than either of your starting values. In this case, they all happen to have 3 sig figs. Don't expect that to be the case always. Alright, so let's take a moment now and have our final learning check for this little subtopic. So from each of these calculations, round the answer to give the correct number of decimal places. So for number 1, 235.05 plus 19.6 plus 2 equals, and then select the final answer that gives the correct number of decimal places. And for number 2, now we'll do a subtraction example, 58.925 minus 18.2 equals, and then select the correct value from those choices. So either make your selections now or pause the video and continue as soon as you're set with your selections for those 2 learning check questions. Okay, so for the first learning check solution, we have the ones place as being the decimal place of least significance. Again, it's not even a decimal place for this example, but because that last value we're adding 2, there's a final result of 257. We got 256.65 because we're looking at the ones place as our least significant value. We'd have to round up because of the 0.6 that follows the 256, and therefore 257. Answer choice A is the correct answer there. For our subtraction example, 58.925 minus 18.2, so the tenths place is now the decimal place of least significance, and we have from the initial value of 40.725, that 0.72 2. We're looking at the hundredths place. It's less than 5. Therefore, we just drop it off to give 40.7. Answer C. So if this is all coming very easy to you, great. That's wonderful. But it's more typical for students to struggle a bit with these calculations involving sig figs. So if you're finding yourself still at a loss for the correct significant figure results, please go ahead and try some additional practice problems from the back of the text or the homework set, and let me know. Reach out for help if you're continuing to struggle, because this tends to be probably one of the more difficult topics, certainly one of the more difficult Chapter 1 topics, and it doesn't go away. We'll continue to apply sig fig rules throughout the course, so please ask for help if you need it. Otherwise, wonderful, great that it's going well, and we'll check in with the next topic.